Okay, pause and copy everything you see here. So we have a quadratic, an irreducible quadratic. What does irreducible mean? Irreducible, meaning I cannot factor it further. So x squared plus 4. Okay, you cannot factor that. Now, here's a pattern we will follow for case 3. Okay, for the linear factor, we do the same thing as we always do. But this quadratic, x squared plus 4, is going to need 2 letters. Okay, these are kind of facts of arithmetic. It could be proven, not very interesting, but the one thing I will say is that I will make you notice that so far, the degree on the bottom, okay, so by degree I mean the highest power of x, is always greater than the degree on top. So degree on top is obviously 2. Okay, 2 is the highest power of x. Now the bottom, it's kind of hiding, but the highest power of x is 3. Okay, so all these formulas I've been giving you absolutely depend on that. Okay, you need the degree of the bottom to be strictly bigger than the degree of the top, or these formulas do not work at all. We'll talk more about that later. Okay, so once I come to my bottom line here, I'm going to do a different method just to give you some options. So what I'll do is expand the right-hand side and collect like terms. So I'm not going to belabor this too much. I'll do it in 2 steps. So I collect all my x squared terms together, all my x terms together, and my constant terms together. And what I say is that the polynomial on the left is equal to the polynomial on the right. And one can prove that this means that this coefficient must equal this coefficient. The coefficient of the x term here must equal the coefficient of the x term here, and the constant terms must equal. Okay, so what we're going to do is what's called equating coefficients. So, as I said, a plus b must be 2. And so on and so forth for the other 2 terms. And what I end up with is a system of 3 equations, 3 variables, and I'm able to solve that. So what do? I say, well, from here it's obvious that a is 1. Then you can plug that in here to get b, and then you're done. Okay, so I found a, b, and c. So I can rewrite my integral. First one's easy. First term is easy. Second term is a bit of a sticky wicket. You have to break this up into 2 pieces. Okay, so I'm breaking this fraction up into 2 pieces. Okay, the x and the 1 on top. Now for the very last term here, I'm going to have you memorize the formula. And then for the term in the middle, that will require a substitution. Okay, this kind of thing takes experience. You have to know that breaking this up will help. Okay, last case, case 4. The ugliest of them all that we will deal with. Now we have a quadratic appearing, and it's appearing more than once. So this is going to be a bit long. I'm not going to be able to show all the steps, but I will give you the important pieces of the puzzle. Okay, so here's the pattern we follow. For the linear factor x, do the same thing as usual. But for the repeated quadratic, we do this thing similar to case 2, where we are, because this is squared, having a term where x squared plus 1 has exponent 1, and then another term where x squared plus 1 has exponent 2. And we stop there because this number over here is a 2. Okay, so multiplying both sides by the denominator here will give me this nice looking thing. And then you're going to have to expand on this lovely thing and collect like terms as we did before. So I'm not showing my work, but there you go. Now I'm going to equate coefficients again. On the left, I rearrange things to make my life a bit easier. Put my x cubed term first. Okay, because I have 1, 2, 3, 4, 5 terms here, I'm going to have a system, a wonderful system. Oh boy, a wonderful system of 5 equations here. Now pause and copy that. Here's my color coding. So with my color coding, I'm trying to give you an idea of how I solve this system of 5 equations, 5 variables. So I start by saying that, well, down here I have A, and with that, I can find B if I just use the first equation. Likewise, if I put the second and fourth equation, that's my blue curves. Put those two together, I can find E. And once I have B and E, I can use the middle equation to find D. And we get a nice partial fraction decomposition, which we can work out. I'm going to leave the details here to you as an exercise. One thing I will say is that this term here will have to be broken up, just like I did in the preceding example. So pause and copy that if you haven't done so already. And here's a nice summary for your notes.